Okay, so in this video, we're going to go over the half angle formulas, and there's three of them. Sine of theta over 2 is equal to plus or minus square root 1 minus cosine theta over 2, and cosine of theta over 2 is equal to this. And then there's two forms of tangent theta over 2. Again, half angle, hence the 1/2 under each theta. The way you arrive from this equation form to this equation form is you can manipulate and multiply top and bottom by 1 plus cosine theta. Again, out of the interest of time, if you really are curious where these formulas come from, you can refer to your textbook. But again, under normal circumstances, I would derive these in class with you, but we are not in normal circumstances. Okay, so notice in the star right here, I wrote the sines plus or minus of sine of theta over 2 or cosine theta over 2 depend on which quadrant theta over 2 is in. And the theta over 2 is basically your given angle that you're asked to evaluate. And so notice you have a plus or minus here, plus or minus here. You're not going to use plus or minus at the end. You're going to pick one or the other depending on the sign that your theta over 2 is in. Basically, whatever your initial angle is in, whatever quadrant is in, that will determine the sign of whether you use plus or minus. Okay, so let's take a look at these two examples here I've written down for you. Find the exact value of cosine 105. And so what I'm going to do right now is I'm going to call this guy right here, this angle, this guy right here is called theta over 2. Okay, so theta over 2 is equal to 105. All right, so if theta over 2 is equal to 105, right, that means theta is just equal to 210, right? If you multiply both sides by 2, theta itself is 210 degrees. So now I can use my angle, my half angle formula, which says that cosine of 105, right, keep in mind this is your theta over 2, is equal to, if I look at my formula again, right, 1 plus the cosine theta over 2, square root, 1 plus cosine of, in this case, I'm going to take the cosine of 210, all over 2. Okay, now, the sign right here, right, I write plus or minus depending on what quadrant theta over 2 is in. Theta over 2, which is 105 degrees, right, this is in quadrant 2. And the cosine of 105 in quadrant 2 is negative, right? Cosine is negative in quadrant 2. So hence, I stick a negative there, okay? So really, the sign over here is dependent on which quadrant your initial angle is in. And your initial angle is just theta over 2. Theta, right, is basically double, right? Multiply both sides by 2. Theta is 210. Okay, the very last thing you have to do is evaluate. And the tricky part on these problems is that you're going to have to simplify all your radicals. So right now, using our unit circle, right, the cosine of 210, right, is the same thing as the cosine of 30 degrees. Right, cosine of 210 is the same thing as the cosine of 30, right? This is my reference angle. But 210, right, it's negative in quadrant 2, so it's negative cosine of 30. So it's negative root 3 over 2. Okay, so 1 minus cosine 210 is negative root 3 over 2, all over 2. Now, if you leave the answer like this, this is technically correct, but you haven't completely simplified, right? You can't have radical in the denominator, because if you split this up, this would be the square root of 1 minus root 3 over the square root of 2. So what I would do over here is, I'm sorry, I forgot to write the square root of 3 over 2 over here. And so if you take a look right now, this is a complex fraction. I would multiply top and bottom by 2. Okay, so the way you simplify complex fractions, multiply by the LCD of 2, 1, and 1. So it's just going to be 2. Okay, so you're going to have 2 minus the square root of 3 all over 4. And if you split up this radical, right, I'll just show you the extra work on this one. Over the square root of 4, right, the square root of 4 is just 2. So your final answer is negative 2 minus root 3 all over 2. Okay, so recall that you can split up root A over B by splitting up the radical in the numerator and the denominator. All right, so if you didn't quite get that example, let's do another one where there's radians involved. So again, if I'm asked to find the sine of 7 pi over 12, right, using a half angle formula, right, call the initial angle, call it theta over 2. So let this be called theta over 2. And if that's theta over 2, right, theta over 2 is equal to 7 pi over 12. If you get theta by itself over here, multiply top and bottom by 2, this 2 is going to cancel off the 12. You're going to get theta is equal to 7 pi over 6. Okay, so basically double this to get theta, right? If this is theta over 2, theta is going to be 7 pi over 6. So now I'm just going to plug it into my formula. The sine of 7 pi over 12 is equal to plus or minus square root of 1 minus cosine theta over 2. So the only thing that's different over here is that there's a minus sign. So 1 minus cosine of 7 pi over 6 all over 2. Okay, so I don't know why I wrote that extra bar there. Cosine of 7 pi over 6. All right, so notice I left out the plus or minus. Now I have to determine my plus or minus sign is dependent on sorry, I'm pointing to this one. The plus or minus sign is dependent on which quadrant theta over 2 is in, right? So theta over 2 is just my initial angle right here. And if you think about it, right, 7 pi over 12, well, that's slightly past 6 pi over 12, right? 6 pi over 12 would be pi over 2. So I'm past quadrant 1, and I'm going to be entering quadrant 2. So this guy right here, theta over 2, is in quadrant 2 again. And the sine, or the y value, right, in quadrant 2 is positive. So sine is positive in quadrant 2. So this guy right here, you could write positive, but typically if it's positive, we don't write anything. Okay? All right, so all that's left for you to do is to simplify cosine of 7 pi over 6. No complex fractions, no radicals in the denominator. So honestly, that's probably going to be the trickiest part of this lesson for most of you. The algebra skills are going to be critical. Okay, so unit circle, right? Cosine of 7 pi over 6 is the same thing as cosine of pi over 6, right? Pi over 6 is my reference angle. 7 pi over 6 is in quadrant 3, and the cosine is negative. So it's negative cosine of pi over 6, and cosine of pi over 6 is negative. Sorry, cosine of pi over 6 is root 3 over 2, but we have a negative here, so negative root 3 over 2. Okay, so 1 minus negative root 3 over 2. This just ends up being plus, right? So two negatives make a positive. And just like I did on the previous problem, right, I have a complex fraction, multiply top and bottom by 2. Okay, so this is all within the radical, so just be careful when you simplify this. Distribute the 2 into here, you're going to get 2. This times this is root 3 over 4. Okay, so just like the last problem, right, I showed you that you can split up the radical. Your final answer is just going to be 2 plus root 3 over 2. Let's move on to the next problem here. Okay, so it says find the exact value of cosine theta over 2, tangent theta over 2, given that cotan of theta is 3 and theta is between pi and 3 pi over 2. So this is another one of those quadrant problems, and you will see that the actual sketch of the triangle is not super bad. The plugging it into the formula is not super bad, but I will warn you that in this problem, the algebra, it gets really, really dicey. Okay, so your radical skills need to be strong, and I'll try to explain a little bit in further detail on how they arrive at the final answer that's completely simplified. Okay, so you know what to do, right? You're going to have to sketch a triangle. So cotan, we said, cotan is the ratio of x over y. So I'm going to write a 3 over 1 over here. Now notice theta is between pi and 3 pi over 2, right? So if I were to, draw my triangle between pi and 3 pi over 2, that puts us in quadrant number 3. And there's my theta, right? Now, how do I label it? Do I just label it positive 3, positive 1? No, because I'm in quadrant 3, right? You know that the x value is negative in quadrant 3. So this is negative 3. And to get a positive 3 over 1, right, the y value is negative 1. Okay? So, you're going to have to remember your trig and how to sketch triangles to deduce that, oh, x is actually negative 3, y is negative 1, because theta is in quadrant number 3. Okay? So if this was never clear to you before, hopefully it becomes a little more clear as you're doing more of these problems that you're sketching the triangle. Okay? So prior knowledge, right, cotan, theta is in quadrant number 3, hence I have to write negative x, negative 3, negative 1, and of course the ratio of those will give me positive 3. All right, so of course when we sketch the triangle, right, we have to figure out what this is. So using Pythagorean theorem, right, r squared is negative 3 squared plus negative 1 squared. R is the square root of 10, okay? All right, so we have our r, we have our y, we have our x. We have all the values that we need to do this problem. So let's start with the cosine of theta over 2. Okay, you'll see the actual process of plugging in is not super bad, but the simplifying takes quite a bit of time. So let's do this problem together. All right, cosine of theta over 2 is equal to our formula. If we take a look, right, it's 1 plus cosine theta over 2. Okay, now, before I plug in the numbers, I need to figure out what the sign is. Is it going to be positive or is it going to be negative? The way you do that is you simply go back to your quadrant right here, your initial problem, divide everything by 2. Okay, so multiply this guy by 1/2, multiply this guy by 1/2, multiply this guy by 1/2. You will get pi over 2, theta over 2, 3 pi over 4. Now you can see, right, theta over 2 is between pi over 2 and 3 pi over 4, would actually put you in quadrant number 2 again, right? And the cosine in quadrant 2 is going to be negative, okay? So my final answer is going to have a negative in front of the square root, or whatever that's simplified here on the right side will have a negative in front. Okay, so again, how did you get that? What sign theta over 2 is in? Divide everything by 1/2 in this initial problem, and then you'll get the theta over 2, or multiply everything by 1/2. Okay, so let's take a look at our formula, right? We need the value of cosine of theta. So unlike the previous problem, right, we're not just doubling it. We have our triangle. Let's compute what cosine of theta over 2 is. Or sorry, what's cosine of theta? Cosine of theta is x over r, which is negative 3 over root 10. Okay, now, do you prefer that we simplify now or simplify it later? It doesn't really matter. Okay, I'm just going to leave it like this, plug it in, and then simplify later. So right now I'm going to write negative 1 minus 3 over root 10 all over 2. Okay, so if you understood that, right, that's really the concept of the new lesson. Everything from here on out, which you'll see in a few minutes, will take quite a few lines in terms of just the algebra skills, okay? So I just wanted to show you that the actual plugging in is not super advanced. To figure out what this sign is, right, you basically divide everything by 1/2, or multiply everything by 1/2, or divide everything by 2, I should say. And now, if you look at the back of the book on some of the odd problems, in fact, this was, I believe this is number 58 in your homework, they will not leave the answer in this form, okay? You have to simplify your radicals, right? You can't have a radical in the denominator, and this is a complex fraction. So by now, you guys should all become experts in complex fractions. Multiply top and bottom by square root of 10. Okay, so if I multiply by root 10, I'm going to get root 10 minus 3. That's in my numerator. Multiply this guy by root 10, that's just 2 root 10. Okay, as I mentioned, the algebra in this problem is quite dicey. You still cannot have a radical in the denominator, right? And so, to get rid of this radical, don't multiply top and bottom by 2 root 10, multiply top and bottom by square root of 10, right? To get rid of that root 10. So keep going here. Okay, root 10 times root 10, well, that is just 10, right? Square root of 100 is just 10. This times this is minus 3 root 10. And root 10 times root 10 is 10. 2 times 10 is 20. Okay, now take a look, right? You're like, is that it? No, you still can't have a radical in the denominator. Technically, right, this is a radical in the denominator. Why? Because if you simplify, right, you're going to have negative 10 minus 3 root 10. In fact, I'm going to erase over here. You're going to have 2 radicals. Square root of 20. Okay, so notice I split up the radical, right, using this rule right here. Okay, so hopefully you can see that there's a radical in the denominator, and square root of 20, right, that's just 2 root 5. So I think I'm running out of space here. Square root of 20 is just 2, right? 4 times 5, which is 2 root 5. Okay, so I told you this problem is going to get dicey, right? The last thing we need to do is to get rid of this radical 5, multiply top and bottom by root 5. Okay, this will take care of the final line right here. In our numerator, right, root 5 times, if you distribute root 5 into this, right, you basically multiply whatever's inside the argument into here. The number that's inside the argument is just 5. 5 times 10 is 50. 5 times 3 root 10, again, 5 times this is just 15 root 10. And root 5 times root 5 is just 5. 5 times 2 is 10. And let's not forget that negative. Okay, so finally this problem is done. Look at the amount of time or work or space that's spent on simplifying radicals. Again, if you're not quite sure how I got this step right here, right, recall root A times root B is root AB. Okay, so just think about this 5 right here, distribute it into this. 5 times this is 50, 5 times 3 is 15. Don't multiply the 5 inside the radical within the radical. Okay, so lots of algebra skills are needed to do this problem. Okay, so I'm going to finish up this problem right here by figuring out what tangent of theta over 2 is. So let's do that. So I'm going to run out of space, but let's keep this problem over here. Okay, so tangent of theta over 2, right, is given by this formula, 1 minus cosine theta over sine theta. So I don't have to worry about plus or minus over here. It doesn't matter which formula you want to pick. You want to pick this equation or this equation, it doesn't really matter. Okay, so we did part A, which was cosine of theta over 2. Now let's figure out part B. What is tangent of theta over 2? And I'm just going to use this one right here. Okay, 1 minus cosine theta over sine theta. Okay, so looking back at our triangle, right, we already have cosine of theta. So 1 minus negative 3 root 10 is 1 plus 3 over root 10. And now you compute what sine of theta is. Sine of theta, right, is y over r. So negative 1 over root 10. That's the value of sine theta. And I'm going to plug it into here. Okay, so if you look at this problem, right, complex fraction, there's radicals, but by now, hopefully you're really comfortable with simplifying complex fraction. This is why algebra skills are so critical, both in math analysis and also in calculus. Okay, so to get rid of this complex fraction, right, I'm going to multiply top and bottom by square root of 10. Distribute, you're going to get root 10 plus 3. Root 10 times root 10 is just 1, right? You're going to have negative 1. And you can move this negative up here. Okay, so when you move it up there, right, make sure you put this in parentheses. Otherwise, if you just put the negative here in front and don't put parentheses, you're going to get it wrong. So negative root 10 minus 3 would be the simplified answer.